Hello ladies and gentlemen. So today is the big day where we use trig functions, sine, cosine, and tangent to find missing sides of a triangle. And this is where we're putting the last 2 days together into one lesson. So you're going to be given a triangle like so, where you're given one side of the triangle and an angle, and then two variables. So that means they want you to find both sides, not just one. And instead of me telling you which trig function to use, like the first lesson was all about tangent, the second lesson was sine and cosine. This is all three of them together. So it could be any of the three trig functions. So this would be one example. So you have this triangle. And the first step, it says here, is using the given angle, identify the opposite side, the adjacent side, and the hypotenuse. So you'll see that I circled the given angle 27, drew an arrow across from that angle to the opposite side, which is x. The hypotenuse is always across from the right angle, so that would be y. And then that means that the other side, the other leg, has to be the adjacent. And in every single right triangle, the hypotenuse and the adjacent side will always form the given angle. So that's another thing that you can look for. So that is step one, is to label the three sides. Now in step two, you're going to set up all three trigonometric ratios, Sohcahtoa. So we're going to set up the sine. So you'll see the sine of 27 degrees is equal to the side opposite, which is x. And then the hypotenuse is in the denominator, that's y. So that is one trig function. Then you're going to set up the cosine trig function. The cosine of the given angle is equal to the side adjacent, which is the 14 side, over the hypotenuse, which is y. And then the tangent function of 27 degrees is equal to the side opposite, which is x, over the adjacent side, which is 14. So we set up all three trig ratios. Now, then what you're going to do is you're going to cross off the one that has two variables. So this one here, I'm going to try to keep my hand steady while I cross it off, because I'm videotaping while I do this. You're going to cross that one off. And the reason why you're going to cross off the one with two variables is because you can't solve for x and y in the same equation. You can only have one variable. But you can solve this one, cosine of 27 equals 14 over y, and you can solve the tangent of 27 is equal to x over 14. So we're going to use this one to solve for y, and we're going to use that one to solve for x. So we're going to solve those others, and if you remember, if I have that set up where the y is in the denominator, I'm going to do the old flip-flop. I'm going to take the y and the cosine of 27 and change their positions. And then I'm going to do 14 divided by the cosine of 27 in my calculator. Once again, make sure your calculator is in degree mode, because I saw some people get some really wacky answers like negatives. That should be a sign that your calculator is in radian mode, RAD. And you want to change it to DEG, degree mode. Okay? So if you have trouble with that, you can take a picture of what your calculator looks like or a screenshot of what your calculator looks like, and I'll tell you what button to push if you need to. You should be able to find it yourself. Over here, this one's different because the x is in the numerator. So this is the one where I multiply both sides by the denominator, which I did, and you get 7.1. Now the last thing I'm going to ask you to do is I'm going to ask you to check your work. So if x is 7.1, and y is 15.7. So if x is 7.1, hang on, let me move my camera. If that's 7.1, and then y is 15.7, well, first of all, that would make sense that these answers could be correct, because the smallest angle of the triangle is across from the shortest side, and then the hypotenuse always has to be the largest one. So this all makes sense, and I'm going to use the Pythagorean theorem, leg squared plus leg squared equals the hypotenuse squared, to check. So I'm going to use the Pythagorean theorem, 7.1 squared, which is the leg squared, plus 14 squared does that equal 15.7 squared? So I squared each of those, I added them together, and I squared 15.7, and I got that on the right side. And you'll see that these are almost exactly the same. Now the only reason why they're different is because in these answers here, I rounded to the nearest tenth. So it's possible that your answers don't come out exact. It's possible that your answers don't come out exact. So as long as they're within a few tenths, then you know that you did it correctly. All right, let's hit another example over here. So in example 2, you'll notice that I changed the way the triangle looked so that you're going to see some different layouts of triangles. So they're not all going to look exactly the same. In this case, you'll notice that the variable was the hypotenuse, and one of the legs was the given number, right? Now, if you look at this example, both legs are the variables, and the hypotenuse is the given number. But you're still going to do it the same way. You're going to circle the given angle, draw a line opposite, find the opposite side, draw an imaginary line from the right angle over to here. That longest side is the hypotenuse, which means the other side has to be the adjacent side. And now I'm going to set up all three trig ratios. And here they are. The sine of the 37-degree angle is equal to the opposite, which is x, over the hypotenuse, which is 22. Sine is opposite over hypotenuse. So the cosine is equal to the side adjacent to the 37-degree angle, which is y, over the hypotenuse, which is 22. The tangent of the 37-degree angle is equal to the opposite, which is x, over the adjacent, which is y, and you'll notice that I crossed that one out because this one is not going to help me. Now I go over here and I solve these. These are the nice easy ones to solve. I don't have to do the flip-flop because the variable's in the numerator. So I just multiply both sides by 22. And I multiply over here both sides by 22. And then I just pop that into my calculator, 22 times the sine of 37, and 22 times the cosine of 37, and those are the two solutions I got. So x is 13.2, and y is 17.6. So if I write that down over here, 13.2 and 17.6. Those are the legs. Once again, check to see if your answers make sense. 37 is the smallest angle in the triangle. 13.2 is the shortest side. 22 is the longest side. It's across from the right angle. 17.6 is the medium side across from this 53-degree angle because these have to be complementary. And now I'm going to go over here. I'm going to use my Pythagorean theorem to check. Leg squared plus leg squared blank hypotenuse squared. Are they equal? Does it make sense? And this one actually, even with the rounding, turned out that they ended up being equal. That's a coincidence, but as long as they're really, really close, then you know you did a good job. So that's it. Show all your work. Do the attached worksheet, and have a good day.